day to you there once again. We want to look at how we can use, you can balance the ionic equation, or how we can write the ionic equation for redox reaction. Now, here we are having the reaction in alkaline medium. So let's look at the question now. The question says we should write the balanced ionic equation for redox reaction between tetraoxomanganate 7 ion. This is tetraoxomanganate 7 ion, MnO4 minus. This is tetraoxomanganate 7. You can see 4 oxygen, tetraoxomanganate. If you calculate the oxygen number of this manganate, that will be what? 7. Manganate 7 ion. And hydrazine. This is hydrazine, N2H4. Tetraoxomanganate 7 ion, MnO4 minus. Now, this is tetraoxomanganate 7 ion, and this is a hydrazine. Now, the question says we should calculate, we should write the balanced ionic equation for redox reaction between tetraoxomanganate 7 ion and hydrazine in alkaline medium. This is an alkaline medium. Now, in acidic medium, we've been able to see how we can do the calculation of these particular ions to atoms. How we do it like that. The step one we are going to take A2. Step one, after we've been able to know this, what is this atom that this one is going to form at the product side? This one as well, we are going to look at the atom that is going to also form at the product side. This one will form, it's going to form nitrogen gas, and this one will form MnO2. MnO2. Now, that is step one. Now, after we have done this, as we did in acidic medium as well, too, you are going to calculate what we are interested in here is what? This manganese here, nitrogen here, nitrogen here. So what is the oxidation number of this manganese here? You have to take note of that first. The oxidation number of this manganese here is +7. If you calculate it, you are going to get +7. While the oxidation number of this manganese here is what? Is going to be equal to +4. So how do I do that? Let me quickly do that here. That will be Mn. No, this oxygen is -2 times 2, -4 is equal to 0. This is in a compound state, there's no charge on it. So Mn is equal to what? This one comes and become +4. So this is what? +4 here. That is the oxidation number of that manganese there. Now, after you've been able to get that, you need to calculate that of the nitrogen here as well too. Nitrogen here, what is the oxidation number? That is 2N. Hydrogen here will be -1 times 4. Plus 1 times 4 is 4, is equal to 0. So you have 2N is equal to what? Is equal to -4. N is equal to what? N is equal to -4 over 2. -4 over 2. That's what? -2. That is -2. So this place, the nitrogen here is -2. While the nitrogen here will be equal to 0. Will be equal to 0. Now, as we have in the definition of oxidation and reduction for loss and gain of electron, oxidation is a loss of electron, which is leading to increase in oxidation number. If you look at it very well, you can see that from -2 to 0, oxidation number has increased because 0 is greater than -2. So this one is oxidation. Where is this? Where we have the oxidation process, and this is going to be the reducing agent. Now, this one, the reduction is what? Gain of electron that leads to what? Decrease in oxidation number. You can see oxidation number is here is 7, and this one is 4 here. So oxidation number has decreased. So this is what? Reduction. And that is going to be what? This is going to be our oxidizing agent. Yes, after you've been able to do that, you move to step 2. So let's now look at the reduction of reaction. In the reduction of reaction, Step 2, reduction of reaction. Let's write it out of reaction. Now, that is going to be MnO4 minus. Now, this leads to, according to what we have here, it leads to MnO2. Now, what do we need to add to the either side? Now, in this case here, you are going to have, unlike what we have in acidic medium, whereby you are going to add hydrogen and water, hydrogen to the reactant side and water to the product side. Here you are going to add water to the reactant side and add hydrazine to the product side. Take note of that. Add water to the reactant side and hydrazine ion to the product side. So we have plus H2O plus OH minus. So let's now balance this equation. Let's balance the equation. Let's balance the equation. We have it like this. So we have manganese 1 here, 1 here. Oxygen is 4, 5. Oxygen 2, 3. That's unbalanced already for that. So let's put what we have here. Let's assume we have what here? How many hydrogen? 2 here, 1 here, 2 here, 1 here. What do we do here? If we put 2 here, this will be 2 here, 2 here. But oxygen will not be able to balance. Oxygen will be 4, 4, 5. Okay, 4 here. What about when you have plus 4? 4 here. Now, oxygen is what? 2 plus 4, that's 6. So is what? 1 plus 4, 5. Oh, what if you have 2 here? So this one is 4 plus 2, that's 6. Manganese here, 1 here. Oxygen is 6. Is 6 here, 2 plus 4, 6. Then hydrogen is 4 here, is 4 here as well. So the equation is balanced now. When the equation is balanced, the next thing you do is what? You balance the charges. Balance the charges. Now, what is the charge that we have here? What do you have here? At this left hand side, that is going to be what? Minus 1, because this is the only charge we have here. Minus 1. And what is the charge we have here? That's what? That'll be what? 4 times minus 1. Is this what? Minus 4. This 4 here times minus 1. That's minus 4. We have 4 here, minus 4 here, minus 1 here. If you try to balance the two together, you discover that this one needs 3 electrons here. So we're having it to be now MnO4 minus plus 2H2O plus 3 electron, which now leads to MnO2 plus 4OH minus plus 4OH minus. Now, that is what we have there right now. So we have 3 here, we have 0 here. So that is what is using into balancing it. Now, we have to now look at the oxidation of reaction. We have to look at what will happen at the oxidation of reaction. That is step 3. Step 3. Oxidation of reaction. So what do we have at the oxidation of reaction? That is what? N2H4 we give leads to what? Let me give a space. Leads to N2, that is N2, yes. That is now. You see that this hydrazine here leads to nitrogen here. So and we need to balance the equation as well. So in that regard, you have to add hydrazine to this side, then add water to this side. Please take note, in alkaline medium, you had hydrazine instead of in acidic medium where you had hydrogen. You had hydrazine plus OH. Now when you had hydrazine here, then this hydrogen will combine with this one to get 4 water plus H2O plus H2O. So after we've been able to get this now let's look at the balancing of the equation. Nitrogen here is 2 here. Hydrogen is 5, is 2 here. So how do we balance that? Oh, well, we have this 4 here. This one is 8 here. What we have here to be What about if you have 4 here? 4 OH, that's 4, 8, 8, nitrogen 2, 2, oxygen 4, 4. Balanced equation. The equation is very, very balanced now. After we've been able to do that, you now look at it. Okay, what is that charges? You have to balance the charge again. That's the next step. Balance the charge. 4OH minus, sorry. This is going to be what? We are having, what we have here? We have minus 1 here. We have minus 4 here. We are having minus 4 electron here, which leads to what? At the product side, we have 0. So this one, we need 4 electron at this side here. So we are having the equation down to become N2H4 hydrazine plus 4OH minus plus okay, that is all like that. That's all like that for that side. NH4 plus 4OH minus, leading to what? Leading to N2 plus 4H2O plus 4 electron. 4 electron. Yes, you can see it like that. The 4 electron that we need at this side has come to this side now. You know that you look at the side that need more electron to balance itself, then you put it there appropriately. After you put it that way now, what you need to look at is that you have to balance the two equations. Now, if you look at the reduction of reaction very well, you see that you're having 3 electrons there. In the oxidation of reaction, we're having 4 electrons there. So balance electron at oxidation of reaction and reduction of reaction. So in that sense, you are going to multiply oxidation of reaction. This is a oxidation of reaction by, you will multiply oxidation of reaction by 3. Look at the oxidation of reaction, which is what we have here. You are going to multiply it by the electron of that reduction of reaction, and that of the reduction of reaction, you multiply it by that electron of the oxidation of reaction. So let's have the oxidation of reaction now. Will now be equal to, this is the oxidation of reaction, that will now be equal to 3N2H4 plus 12OH minus, I'm multiplying everything by 3 now, will give us 3N2 plus 12H2O plus 12 electron. Why are we doing this? We are interested in eliminating these electron, that is, the balance, the electron at the reactant side and that of the product side must balance each other. So now at the reduction of reaction now, the reduction of reaction, so let's write it out. This score is going to be equal to, we are going to multiply that one by 4, don't forget. That's 4 MnO4 minus plus 8H2O plus 12 electron. It will give us 4 MnO2 plus 8OH minus 8OH minus. You can see what we are having there. Now, the next thing you do now is that you have to bring the reactant of those oxidation and reduction, bring them together, and reactant of those reduction to bring them together as well. So let's see what is going to happen there. So we are having this to be there. This is going to be what? 4 MnO4 minus plus 8H2O here. Do you have any other water there? 8H2O. There's 12H2O here. That's going to be plus 8H2O plus 12 electron. 12 electron plus we have this 3N2H4 plus 12OH minus. You see, this is what is at the reactant of the oxidation reaction. What's at the reactant of the reduction of reaction? So this one will lead to this is the product now I'm forming. Will lead to what? 3N2 plus 12H2O plus 4MnO2 plus 8OH minus 8OH minus. So we have it that way. 4MnO4 plus 8H2O plus 3N2H4 plus 12OH minus is into what? 3N2 plus 12H2O plus 4MnO2 plus 8OH minus 8OH minus. Now, what do you have there? OH. Okay, let's look at the OH of this oxidation of reaction. Oxidation of reaction. This is it. We have the hydrazine there, which is 4 before. What do we multiply to the oxidation reaction? We multiply 4 by 8. We multiply everything by 4. Look at it. This should be 16. This will be 16 OH minus. This is 16 as well. You know, we multiply everything by 4. 4 is what? 4 OH minus MnO2 plus 4 OH minus. This is it here. You know, we say that we should multiply the reduction of reaction by 4. It's 16. 16 that is going to be there. This is 16 OH minus plus 12 H2O plus MnO2 like that. So that is how you solve the question of this nature. Sincerely speaking, if any question of this nature comes out for you, I believe that by the time you are able to follow this step accordingly, you'll be able to get the answer properly. Please do stay tuned to our lecture room and make sure you watch our class always. Thanks. God bless.